Hi there! Today we are going to build a sideboard for this hull, and the sideboard that I will make will be as thin as possible. The other one that I made for the other hull is a little bit wider and hollow, so it can let water in when it's lowered and let water out when it's raised, and also when you carry it on land, making it a bit lighter. But this time I will do it a little bit differently. I will make it as thin as possible instead. Still, it needs to be heavy enough to be easily lowered into the water. But it doesn't actually need to be that wide. So let's start with that. I will use steel sheets as the heavy component in this board, just as I did with the board for the other hull. I will need an about 43 cm wide sheet, rounded to swing around in the case. About 84 cm long to fit in the case. Having all the measures, I can draw the outline of the board. To allow the board to swing forward in front of the axle, I will cut out material where the hull is. The cutting will have to be done outside, as there will be some sparks flying around when I use the angle grinder. There are some leftovers from the board that I might be able to use to shape a profile. To better bond epoxy to the steel plates, I create some cracks in the surface. I also wipe off the grease from the steel sheets with some alcohol. I will use a 300 gram per square meter glass fiber cloth to bond the two steel surfaces together, and to encapsulate the rust-prone steel from water. This piece of the boat doesn't need to be light, so this heavy but sturdy cloth is actually beneficial. I wet out the cloth with epoxy. A low viscosity is beneficial for wetting out the cloth. A roller is also useful to remove air from the cloth. I add another steel sheet to create a reasonable heavy core in the board, and fixate the two steel layers and the gluing glass layer in between with clamps. Some heavy buckets also helps with the pressing. The next day I can plan the layout of the extra pieces. Also, these needs to be bonded with glass. When all is planned and set for this layer, I start wetting out the cloth. I use somewhat thickened epoxy here as well. The cotton fibers helps filling the cloth, although pure epoxy wet out better. I place the pieces as close to each other as possible, and with the buckets on top there will not be much voids. As I cut the glass cloth to cover the whole board, I also wet out the rest. The next day I can remove the buckets and face the edges. The part of the board above the waterline doesn't need to be heavy. So here I will glue on a 4 mm layer of plywood to make this part about the same thickness as the lower part of the board. When I encapsulate in this part with glass, it will be watertight. And being the same thickness as the lower part, it will swing smoothly, as well as provide side support for the forces acting on the board. Also on this side I plan the layout before I start. The same medium thick epoxy is mixed and used to glue on this layer as well. Especially under the plywood sheet, it's necessary with a thick layer of epoxy. As wood absorbs some epoxy, I wet both bonding sides before I lay down the sheets and press them together. The day after I can remove the markings from the clamps and trim off some excess. I need to prepare for the swing hole, as this board will also pivot. The hole will be strengthened with stainless steel plates, so I cut a 2 mm deep recess into the plywood and place a center 9.5 cm from the radius. Removing material around the hole will allow me to place a plate level with the surface. Now I can prepare some more epoxy to face the edges around the steel plates, fill voids and fill the recess before I cover the hole with a sheet of glass. I mix some more epoxy and wet this out. After this layer of glass I could be done with this side, but I'm not happy with the surface yet. So I add more glass to create the profile I want over the board. An even profile that is thickest forward of the middle. The day after I can flip the board and start laying out the material on this side. The process is repeated with pre-wetting the surface, adding cloth, wetting out, removing air, adding plywood and extra steel plates to create a similar profile on this side as well. Cutting more glass to add more material to make the board more rigid and watertight. The edges needs to be smoothened out with several layers of glass. I also add some glass fiber cutting to increase the thickness. With more glass I can level out the cuttings. Here in the front of the board I keep adding more glass to get the same thickness as in the back, but with some more impact strength. The edges around the board are not nice yet, so I trim off material. Outside I level the surface and the edges. Where there is more material to remove, I find it easiest to use an old handsaw and only do the fine trimming with the sander. During leveling I find that I will need to add some more material, a small extra strip. Inside again I reopen the swing hole so that I can test fit the board and see if I need to remove or add material. It's a bit tight here in the back end, so off it goes. Now I need to add the extra strip and cover up my iterations so that it blends in well with the wrist. Of course the edges need sloping and after filling several times. On the second side I forgot to install the stainless steel plate, so I need to prepare a recess here as well and install the plate and cover this as well in wetted glass. More edge facing and after filling. The day after I open the swing hole so that I can test fit the board in the slot. Mark where to make a pull hole and what material needs to be trimmed off. In the back end I will make a pull hole at the hull edge. This is to make it possible to lift the board with a line. Moving outside to trim down the excess that stops the swinging at the top and at bottom, as well as sanding to prepare the surface for fairing. All blank spots needs to be dulled. Inside again I prepare the edge for glassing over. I tape a thin cloth to the board on one side before I flip the board. Check the surface for low spots. Now I can prepare a strong filler for the edges, using glass fiber cutting mixed into the thickened epoxy. I fill the edge with the thick filler and fold the glass cloth over the edge. With masking tape I will press the cloth and the filler in place, creating a rounded strong edge. I use up the excess to fill some low spots in the surface. The day after I can remove most of the masking tape and sand the area around the edge, as well as the surface where I added material, before I move inside again, to check that the edge works with the slot. During sanding of the edge I sanded through the glass, so I need to add a thin strip to cover this up. Then I add fairing compound to the low spots and level this out with a rubber scrape. After this I need to reopen the holes again before I put fairing compound on the other side. Level this out as well. Last cure outside for this episode. Now I just need to sand the surface smooth. And the board is ready for painting.